Будет лекция Spilantini, Италия. Название он сам объяснит, вблизи ошибки речевой в окрестности, которой мы находимся.
Но я объясню все по-английски, потому что по-русски будет труднее для вас, чем для меня. Вот. Так, сейчас если должен... Вот. Antimatter in the Universe is a very ambitious title, but I will speak essentially of one item specific, that is the asymmetry of universe in matter and antimatter. That is a very important item of physics, and I will try to introduce with some elementary reasoning the argument. After that, I will go in some more technical things, experiments and technical things. And what is it?
No. Page down.
Page down. Page down.
Ah, yeah, page down. Okay. So, I will begin with the historical sentence of Dirac again, and that as we formulate the famous equation, in this equation will contain a symmetry of electron and positive. In fact, was electron also was in the interpretation that came out that of positons. In the case when this happened in a lot of time before this lecture of 33 of Nobel lecture, so at the time was very clear that he made the hypothesis of existence of positons. We must regard it rather an accident that the Earth and presumably the whole solar system contains a preponderance of negative electrons and the positive protons. It is quite possible that for some of the stars it is the other way about. And this was really I don't say what is rompicapo. What is in English also, I don't know the word. Something
Rompicapo.
Headache, something that was very difficult to imagine. How was possible to answer to these questions? These are all written because I have very old transparency that I could recover and to introduce the argument. The question was, how can the universe contain an equal amount of matter and antimatter? Because it was very natural to think the universe, already the Big Bang was something that was acquired by physicists, this idea, and it was natural to think the universe must contain an equal amount of matter and antimatter. And for about 30 years, no people could answer to this question. The problem was how to separate the matter from antimatter on large scale, because as you know, if two particles they meet, immediately they produce energy and they disappear, they transform into particles. So the big models, based on statistical fluctuation, they could not construct a separation between matter and antimatter, and also they could not construct objects so big as are the objects in astronomical scale. For example, the maximum in some articles they could construct objects of 10 to minus 30 of the mass of the galaxy. Also, there was another point that the number of baryon, the ratio between the baryon and the photons, was really very, very small. The so-called annihilation catastrophe. Instead, the experimental value is about 10 to minus 9. Because f at the beginning, that is something that more difficult to explain, but at the beginning the ratio with the barrier and the photons was about 1 at the minus 35 seconds after the Big Bang. The annihilation disappearance of matter produces these kinds of ratio. And the problem was could be solved. It's not solved, but could be solved after the discovery of CP violation in nature. After a few years, Sakharov formulated in a small article, 3-4 pages, the hypothesis, and this hypothesis is possible to imagine disappearing of antimatter and the appearance of the preponderance of matter. The first was that the baryon decay was permitted. The second hypothesis was that exists CP violation, a third that the period of non-equilibrium in the universe. As you know, this is true because the universe is expanding. The second was already discovered in one of the system of chaos. It could be perhaps more general. The third, the first hypothesis at that time was a real hypothesis because still didn't exist theories that could foresee the decay of baryons. Now we know that the people is trying to experimentally to find this. The physicists think that the baryons are not stable. Under this hypothesis, it could be constructed a Lagrangian universe where the CP violation is inserted in the Lagrangian, so we have only matter in the universe. But also we can think in another manner. This hypothesis offers a solution to the matter-antimatter separation problem in a baryon symmetric universe. We have somewhere spontaneous break of CP, violation of CP. So in some domain of the universe we have or matter or antimatter, and the inflation mechanism can increase these domains to astronomical scale. Inflation mechanism is something that happened a short time after the Big Bang, when I cannot explain this because I'm not a theoretician, so okay, in the case I can explain, but it will take a lot of time. It's out also of our. In any case, these domains can be expanded at the astronomical scale by this. However, the theory is not, that can support the baryon asymmetric universe is not complete because or an hypothesis or these domains are still things that must put from outside, and our present understanding does not forbid a baryon symmetry. In effect, if we look around us, we have a limit on the existence of matter on antimatter. It is about 10 to minus 5 in a region that is about 100 megaparsec around our point in the universe. That is a very small region, 10 billions of the universe. So in effect a very, very local phenomenon. And so we can extrapolate from this that all universe must contain only matter. And how can we have some insight in what happened outside of this 10 to minus 8 of the universe? We can only investigate by direct or indirect observation if our universe is symmetric. Indirect observation is by studying the spectrum of gamma, because of which see why. What we can observe. The other is to observe directly antinuclei. If we have only one antinuclear, really is sure that must be produced by an antinuclear.